Often in geometry, we're going to be working with things called conditional statements, or what we will probably more likely refer to them as if-then statements. So sentences that begin with the word if and have the word then in the middle. So a couple of vocabulary words associated with if-then statements. If you look at the statement in the center, if you study hard, then you will pass geometry. So we call the if part the hypothesis, which you've heard that word before, and we call the then part the conclusion. So what we're going to try to do first is take these statements at the bottom and write them in if-then form, or write them as a conditional statement. So let's take the sentence, all birds have feathers. Now, sometimes you may have to add a word or two to make it make sense. You want to always remember start with the word if and have then in the middle. Don't add too many words. Don't change the meaning of the sentence. People sometimes add way too many words. And we want to try to keep things in the same order. So something about bird should come first and then feather should sort of come at the end. So the way that I worded this was if it's a bird, then it has feathers, simply like that. Some people have said if an animal is a bird, then it has feathers. But notice if is at the beginning, then's in the middle. Next up, we have a square has four sides. And again, we want to try to phrase that in a way that will make sense without adding too many words, but get the if-then format. So I came up with if a shape has, or if a shape is a square, then it has four sides. Now you may have seen me erase real quick. Sometimes that happens with these. You write something or you start to write and realize it's not going to make sense. It's going to sound awkward. So rephrase it in another way. Next up, we're going to work with things called the converse, the inverse, and the contrapositive. What these are going to do is going to take our if-then statements and sort of switch things around in them. Sometimes we'll negate certain parts of it, meaning we're going to add the word not to the sentences, and a combination of these things. So let's go ahead and take our first statement, perpendicular lines form right angles, or 90-degree angles, and let's go ahead and write that as an if-then statement. So I wrote this as, if lines are perpendicular, then they form 90-degree angles. Well, next up is the converse. Converse means you're going to switch your hypothesis and your conclusion. It'll still start with if and end with the word then, but you may write this, for example, if lines form 90-degree angles, then they are perpendicular. So you can see that I've switched the if and the then parts. Next up, we have the converse. The converse is going to be the first one of our terms that negate part of our statement, meaning we're going to add the word not. So the inverse is going to take the original if-then statement in that order, but add the words not to it. So for example, if lines are not perpendicular, then they do not form right angles. And then finally, we've got the contrapositive, and this does both. It not only switches the inverse, or it switches the hypothesis and conclusion, it also adds the word not to it. So we'll say if lines do not form 90-degree angles, then they are not perpendicular. What we can do is we can also go ahead and do a truth test with this and go through and see if the statements are true or false. So sometimes just because the original statement is true, which it is in this case, your inverse, converse, contrapositive may or may not be. But as you go through and read all these statements, each one of them turns out to be true. So I'll put a little T, meaning each of these statements are true. That's not always the case, though. And one more phrase we'll look at. The phrase or the sentence is guitar players are musicians. So let's go ahead and do the same thing, practicing writing our if-then statements as well as our converse, inverse, and contrapositive. So first up, just let's take that phrase and add the words if and then, keep things in the same order. So I could say if you are a guitar player, or if you play guitar, then you are a musician. After that, we'll switch. So we'll say if you are a musician, then you play guitar. The converse is going to add the word not. So if you do not play the guitar, then you are not a musician. And finally, the contrapositive switches and negates. So if you are not a musician, then you do not play guitar. And then I was just saying a minute ago about the truth test. Let's go ahead and see what the statements say, or whether the statements are true or false as we go through this. So start with the if-then statement. If you play guitar, then you are a musician. That's true. If you can play guitar, you're good at music. Next up, the converse, though, if you are a musician, then you play guitar. That's false. Maybe I play the saxophone or the xylophone or something. The inverse then was if you do not play guitar, then you are not a musician. Again, that's false. Maybe I play a different instrument. I could still be a musician just because I don't play guitar. Does it mean I'm not a musician? And then finally, the contrapositive, if you are not a musician, then you do not play the guitar. That's true. If I'm not good at music, then I can't play anything. So that's a true statement. And just one more kind of statement we can write is something called a biconditional statement. The biconditional statement will always contain the phrase if and only if, and you're going to see that appear in the middle of the statement. So let's take a look at what we want to write as a biconditional statement down here. It says parallel lines never intersect. Well, first of all, we have to make sure that that's a true statement, both in the if-then form and in its converse form. So if I thought of that sentence as if then, I could say something like, if lines are parallel, then they never intersect, which is true. And then if I took the converse and switched that, I'd say, if lines never intersect, then they are parallel, which also is true. So because I verified both of those, I can write this as a biconditional. Again, it may take a little bit of rephrasing to get it to sound right, because you want the word if and only if to appear in the middle of the statement. So what I came up with was, lines are parallel if and only if they intersect, or if they never intersect. And one big rule of geometry is that we're never allowed to assume anything from a diagram. So continuing this idea of logic, if I take a look at these statements and I want to test if they're true or false, I'm not allowed to assume, so I have to go by just what's given to me in the diagram. So this statement is saying line BD is perpendicular to line AC. Well, that I know is going to be true. I can prove that. There's nothing I have to assume. I can see that little right angle symbol there, which means the lines are perpendicular. They do meet at right angles. Compare that to the statement on the right, which says M is the midpoint. Well, certainly M looks like it might be the midpoint of segment FH, but nothing in the diagram tells me it, and I'm not allowed to assume this. So I'm going to say that this is a false statement. I don't have enough evidence to prove it. What I would need is something like tick marks to show that those two segments are equal, or lengths, but I don't have that, so I cannot assume it. I have to say that's a false statement. And lastly, with this topic of logic, we're going to talk about counterexamples. Counterexamples are just proof that something's false. So, for example, let's take a look at this first statement. Earth is the biggest planet in the solar system. Well, I know for sure that that's false. They want to provide a counterexample, so all I could say is, well, Jupiter could be my counterexample because I know Jupiter is bigger than the Earth. Next up, they say 2 is the only even prime number, and I may start to think and try to find a counterexample. Maybe I'll try 4, but 4 is not prime, or 100, but 100 is not prime. And pretty soon I realized that any even number is going to be divisible by 2. 2 is the only one that's going to work because 2 and 1 are the only divisors of that, the only factors of that. So this is in fact a true statement. I can't come up with a counterexample. And then lastly we have the statement, if x is a positive number, then taking the square root of x results in a smaller number. Well, I might again try a couple examples and see what happens. So if I try the square root of 100, that equals 10. So that is true according to this statement. I take a square root and I get a smaller answer. If I'm careful though, I may try something like the square root of 0.5. And if I try that, I'll find out that the answer is actually 0.25. So I get did I do that backwards? Hang on. Oops, see, I'm trying to do too much math in my head and not looking at my notes. So let me rewrite that one. That's actually wrong. I wanted to take the square root of 0.25 and see that actually comes up to be 0.5. I had it backwards. So I did start with a smaller number and got a bigger number. So that could be my counterexample proving that this statement is in fact false.